All right, guys. I don't remember what problem number this is. 25. All right, guys, there's a homework question on problem number 25. We're going to look at it first before we start the lesson today. Number 25. So we want to solve this quadratic equation here, x squared plus 6x plus 3 equals 0 by completing the square. Our first step in completing the square is a equal to 1. If not, make it so. Well, yes, the number in front of x squared is 1. So we can move on to step number 2. Second step is to get the constant term by itself. So we can subtract 3 from both sides, leaving us with our x squared plus 6x plus blank is equal to negative 3 plus blank. We want to get the constant term by itself, so we want the variables on one side, constant terms on the other, and leave 2 spaces. Our third step is to find the value of c.
That would be 6 over 2 squared.
b over 2 squared, so 6 over 2 squared. Now, 3.
B squared is 9.
So finding c, we do b over 2 squared, which would be 6 over 2 squared, which is 3 squared, which is 9. So we plug 9 back into our 2 spots. So the value of c squared goes back in both of our spots, so 9 and 9 in this case. Now when we factor, we have x, and the number that goes in here with x is the number and sign we have before we square it, which would be our plus 3. So that's where I think you were getting those two flipped. Does that make sense?
Yeah.
Yeah. Now the other side, negative 3 plus 9 is 6. Questions on this so far? Now at this point here, we can start solving by taking the square root of both sides, and here the square root and square would cancel, telling us that x plus 3 is equal to, plus or, guys, let's focus in, plus or minus square root of 6. All right, guys. Subtract 3. Did that answer the question? So I'd look back at the others and see, because from what I saw, you were doing it right. It was just that one flip. You just had those two terms, what we plug inside the parentheses and what we actually add. Flip. 32, yes. So was it 31 or 32? 32. All right, guys. All right, guys. Let's focus in. So we're looking at 32, which is 6r squared plus 6r plus 12. And luckily for us, all three terms are on the same side, or they're all together. We don't have r's on both sides, r squares on both sides. We do have them collected. Now, first step, is a equal to 1?
No.
No. If not, make it so. So we have to divide everything by 6. And when we do this here, we'll get r squared plus r plus 2 is equal to 0. Now we can move on to step 2. So we need to get the constant term by itself. And we can do that by subtracting 2 from both sides. Now I feel like you're probably comfortable enough getting to this point here. Yes? Now the value of b is what? 1. So when we find b over 2 squared, we plug 1 in and get 1 over 2 squared. Does 1 over 2 reduce nicely? No. So we'll leave it as 1/2. Now 1/2 squared is 1/4. So we're going to plug 1/4 back in both spots. Now when factoring this with 1/4, well, it's not going to be any more difficult than what we already have, because we will still have our set of parentheses squared, and the number and sign that goes inside here is the number and sign of what we have inside the parentheses before we square it, which just tells us this factors to x plus 1/2 squared. -2 plus 1/4 is -7/4. Questions on how we got to this point here? At this point here, we're going to square root both sides. Now here, the square root and square will cancel, telling us that x plus 1/2 is equal to plus or minus. Now, reducing this radical, there's a few things that we have. One is that this negative is going to come out as I. Now, what that leaves us with is the square root of 7 over the square root of 4. Now, looking at this here, what would the square root of 4 be? Well, square root of 7 doesn't reduce. So the square root of -7/4 is actually the square root of 7 over 2i. And we could do that in the 30xs. If I can pull it up, draw that out, say fraction square root of 7 over the square root of 4, 7 squared root of 2. And last but not least, we need to subtract the 1/2, telling me that x is equal to -1/2 plus or minus the square root of 7 over 2 I. Yeah, because unfortunately, especially with the negative square root of -7/4, the graphing calculator can deal with the I part of it. It's just going to convert the square root of 7 into a decimal, which isn't helpful. There are ways I've seen, I've not looked deeply into it, to simplify or find the square roots and see what they reduce to in simplest radical form. It involves multiple steps and involves graphing. Where the 30xs, we just remove the negative and it does everything for us. I don't see why dig all the way into that if the other calculator does it nicer, easier, and simpler. But questions on this here? Questions on, so we kind of feel comfortable with how this works, yes? Now, solving wise, with solving, the first main way we went about solving was factoring. It's been a minute, but we've factored. We got it in factored form. 2 or more things multiply together equals 0. One of them has to be 0. We set them equal to 0 and solve. Now, the second one we had was graphing, which probably for a first out of any way to solve graphing probably wouldn't have been your favorite out of all of them, but I think so far in this chapter, especially with the graphing calculator, graphing has been the nicest way to solve it, especially if we have integer answers, because we type it in, graph it, it tells us immediately what the answers are. The third way we had was our square root method, which worked pretty well as long as we had either no middle term, we just had an x squared, or a variable squared term, or a single set of parentheses squared. All of these worked well if it was set up or had a certain type of factors or solutions. It worked well in those cases. Now, the first one that we got that worked for all is our completing the square. The one method we just did. Completing the square works for all quadratics. It doesn't matter the setup, doesn't matter what type of solutions, it works for all of them. Now, really, if we think about it, the square root method, guys, let's focus up here. Square root method is just taking the square root method and making it work. Really, that's all this is, but it does work on all of them. It does not matter the starting point of the quadratic, as long as a, b, and c are, we have three real numbers. The quadratic, or our completing the square, will solve the quadratic equation. Okay? Now, the next thing I'm going to do, the next thing I'm going to go over here, you do not have to write. Because there is one other way to solve quadratic equations, and that is the quadratic formula. It, I would say, is probably not as well known, or not, when I say well known, I mean, if you ask somebody randomly what the Pythagorean theorem is, most will know what that is. Most likely, especially when we see the quadratic formula, you'll be familiar with it. You've at least seen it somewhere. But what we're going to be doing, well, what I'm going to be doing here is showing you how we get the quadratic formula, where it comes from. Now, you do not have to write this out, because again, I'm doing this and going through this process so that y'all know where it comes from, how we get it. Now, for the most part, where we get it and where it comes from isn't essential, it isn't important, but it does kind of help us see that there is some rhyme or reason behind us being able to use this formula, that it comes from somewhere, than just be given a formula and going from there. Now, what I'm going to be doing is taking this here, ax squared plus bx plus c. This is the general form for any quadratic equation. We've seen it a few times up to this point. We kind of know what it is. And what I'm going to do is exactly what we just did with the homework problems. I'm going to solve this using the quadratic equation. Even though we don't have numbers for a, b, and c, we can still apply it to it. And the reason that this is helpful is because if we can apply this to it and get x by itself, it means that we can use that equation for any value of x. Now, the first thing we would do is get a equal to 1. Well, and again, a is a value. A could be anything. So what we're going to have to do is divide everything by a. Now, our ax squared divided by a, guys, we'll focus up here. Ax squared divided by a is just going to be x squared, because the a over a simplifies. B over a doesn't simplify, c over a doesn't, and 0 divided by a is 0. So we just divide everything by a. Now at this point here, we got a equal to 1, so we need to get the constant term by itself. So to do that, we're going to subtract c over a from both sides and leave two spaces. So again, you don't have to write this down. Because again, I'm just going through this so that y'all can have seen it. You know how it works. Yeah. All right, guys. Yeah. You don't have to write this. I'd more watch to see how this, because again, this is just getting to the formula. So these are our first two steps. Now our third step, we do get some, we're trying to find this third term, which is our b over 2 squared. Now the b, in our case, is the general term b over a. We're dividing it by 2. Now the process, I'm not going to go so much through the particulars of this here, but when we divide b over a by 2, we end up getting b over 2a. And if we square this, we square both terms. B times b is b squared. 2a times 2a is 4a squared. Now the factoring of this here is actually not too bad. Because again, just like we factored the last ones, especially on the homework, it works the exact same because we have x. And what goes inside this parentheses here is exactly what's inside this parentheses here before we square it, which is positive b over 2a. Now we do need to add these two here, and it's probably been a while since y'all have had to add fractions, let alone expressions like this here. But we would have to get the denominators to be the same, which is our 4a squared. Now to do that, actually, I'll go on and write this out, because we did negative c over a plus b squared over 4a squared. The negative c over a does have an a, but the denominators have to be the same. What it's missing is the 4 and another a. So we multiply it by 4a. Now what that gives us is negative 4ac over 4a squared plus b squared over 4a squared which is where we got the negative b squared minus 4ac all over 4a squared. Now, at this point here, we're going to square root both sides. The left side's nice because the square root and square would cancel, giving us x plus b over 2a is equal to plus or minus. All right. The numerator is going to be the square root of b squared minus 4ac. Now the denominator does simplify a little bit. We can take the square root of 4, guys, which is 2, and the square root of a squared is a. And lastly, we can subtract b over 2a from both sides to get x by itself, which is telling us that we have negative b over 2a plus or minus square root of b squared minus 4ac all over 2a. Or really, we can combine this to get our formula. This here. So what this is telling us is that the quadratic formula, well, this is the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a is what we have with this here. And really, for any quadratic equation with real numbers a, b, and c, we can plug those values into this equation and get our solution. We can plug them into this here and find the value of what we're looking for here. Thank you, sir. Now, that whole process of getting to it, you're not going to ever have to do. Again, I did that so that y'all can see it, you know where it comes from. Because this works, and the reason this equation works is really we just applied completing the square, which solves for any quadratic to the general form. And now we just have to take a, b, and c's values, plug them in for a, b, and c, and simplify. So, let's actually apply this to this here. So we have this quadratic. You don't have to rewrite it. I'm going to rewrite it here. Now, one of the main things with the quadratic equation for us to be able to use it is that our quadratic has to be equal to 0. This one here is not equal to 0. So to get it equal to 0, we're going to subtract 5 from both sides, telling us that we have x squared plus 3x minus 5 is equal to 0. Ax squared plus bx plus c. A is the number in front of x squared, and what's our number in front of x squared? Number in front of x squared is positive 1. Number in front of b, positive 3. And the number for c, negative 5. Our quadratic equation, quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Questions on how we found a, b, or c before we start using this equation? So we have negative b. Well, negative, what's the value of b? 3. Plus or minus square root, so b squared, we plug in the value of 3. B is 3, so we have 3 squared. Minus 4 times a, well, a is 1, times c, which is negative 5. Questions on how we plug anything into the top of this equation? Well, the denominator is 2a, so 2 times 1. Questions on what we've done so far? Really, all we've done is what? Take a, b, and c and plug it in for what? a, b, c, yes? We feel comfortable with this so far? Okay. Now we need to simplify. So the first thing we're going to simplify is negative 3. Negative, parentheses 3, close parentheses. Our first, let's get a highlighter. This part right here. Well, what would that be? Well, it would be negative 3, yes? Plus or minus? We'll deal with the square root in a minute. Let's look at the bottom. The denominator is what? 2 times 1, which is? 2. Okay. Let's take care of those two pieces first. Well, next thing I do when I solve these here is I look at what's inside the radical. I'm not so worried at this point about the square root. I'm more focused on, in this case, the 3 squared minus 4 times 1 times negative 5. Now we could do this by hand, which would be squaring the 4, then multiplying the 4 by 1 by negative 5, and then subtracting. The other option is, parentheses, 4 squared minus 4 times 1 times negative 5. Yes, I was wondering why that worked out nicer. Yep, let's try it again. 3 squared minus 4 times 1 times 29. Yep, that looks a little more correct. Because if it was 36, that would have simplified nicely. 36 we can take the square root of. Now 29 goes right there. Because our 3 squared minus 4 times 1 times negative 5 is 29. So it tells us we're having to take the square root of 29. Well, questions on how we got to this point here before we start trying to simplify further? Now the question is, why didn't we just type it into the 30xs as the square root of 3 squared minus 4 times 1 times negative 5? And for this one here, we could have done that. Because square root of 29, it will do it, it's fine. The only issue we might have is if instead of getting square root of 29, it gave us square root of negative 29. 30xs cannot do a square root of a negative. It's going to throw it out as domain error. The 84 plus, it can take the square root of a negative, but the square root of negative 29 is going to be a decimal if it doesn't reduce. Square root of 29 is it doesn't simplify, it doesn't reduce. That is the answer. We're done. So really, once we find A, B, C, and plug in, it's just simplifying each of the different parts down, and then we're done. Questions on this here? We ready for the next one? Fortunately. So we're going to do this one and 2 more, and then we'll be done for the day. We're just doing the first page. We'll finish this up tomorrow. So 3x squared plus 4x equals 10. First thing we need to do is get this thing equal to 0. So we can subtract 10 from both sides, giving us 3x squared plus 4x minus 10 is equal to 0. Because our first step in using the quadratic formula is to get this thing equal to 0. ax squared plus bx plus c. Our value for a, in this case, is what? 3. Value of b is 4. And value of c is negative 10. Negative b plus or minus square root of b squared minus 4ac all over 2a. So negative b would be negative. We'd plug in 4 for b. Our b squared would be 4 squared. Our a is 3, so we can plug 3 in for a. And c is negative 10. AC. Yep. Negative 4 AC. It looks like AE. Questions on any of this here so far? Now our negative 4 is going to reduce to, well, negative 4. Plus or minus square root. The denominator, 2 times 3 is 6. Now the only other thing we need to reduce at this point is our 4 squared minus 4 times 3 times negative 10. Squared minus 4 times 3 is 136. Questions on how we got to this point here? Well, let's check and see if the square root of 136 reduces. It does indeed. Negative 4 plus or minus. It does not reduce to a single number, no. But it does reduce a little bit, because we can take it from the square root of 136 to 2 square root of 34. Questions on how we got to this point here? Do our top two numbers and the number on bottom have a common factor? They all have a common factor of 2. So at this point here, for us to say that we have it, our final answer, we do need to simplify this. We need to remove that factor of 2 from all three terms. Now there's different ways to do it. One of them, what are we doing? We're removing that 2 from all three terms. We're dividing each term by, so negative 4 divided by 2 is negative 2. The 2 square roots of 34 divided by 2 is just the square root of 34, because the 2 factors out completely. 6 divided by 2 is, so that's it there. Really what we're doing is we're factoring out the 2 out of the top. And if I factor the 2 out of negative 4, we get negative 2, plus or minus. If I factor the 2 out of this 2 square roots of 34, we have the square root of 34. Which does give us a multiplication, something we can actually reduce, because 2 over 6 reduces to what? 1 over 3, leaving us with our, this here. No, you don't have to write that down, because it's essentially, it is exactly what we just did on the previous one. The one way we did it, the way we did it first, was just a shorthand version of what we just did. We divided the top 2 by 2. We divided negative 4 and 2 squared of 34 by 2. And we also divided it out of the 6. We just reduced it all by a factor of 2. And for any of these here, and especially the homework you turn in, if not all 3 factors have a common term with them, like here they're not all 2. I'm going to change this for a second. Let's say that this was 5. We leave it as that. Because if it doesn't factor out of all 3, we're not going to factor it. It's just going to make it more complicated than it's worth. Okay, apparently it's not putting the 2 back. All right, whatever. Questions on this here before we look at the next one? All right, guys. X squared minus 6x plus 4 equals 0. There is something nice about this one. It already equals 0. All right, guys. ABC. The value of A in this case is? Value of B. Negative 6, and C is 4. 4. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So our value b is negative 6. So at this point, we can plug it in our two places where b shows up, our negative b and b squared. Our value of a is 1. So we can plug it in into its two spots, and c only shows up once. So we plug in its value. So we're just plugging in the values of a, b, c. Questions? AC. Any other questions on this here? Now the next part we have is negative, negative 6. Well, negative, negative 6 is positive 6. The denominator, 2 times 1 is 2. Now we need to figure out what's inside our radical. So we have negative 6 squared minus 4 times 1 times 4, which is 20. You know what? While we're here, let's take the square root of 20. So it is 20. I can't hold on to anything. It drops off eventually. Now, yes, if we wanted to, we could technically jump from here to here. Because that middle step, all we're doing is taking what's inside the radical, negative 6 squared minus 4 times 1 times 4, plug it into the calculator. Since we found out it is positive 20, we can go and just take square root, get 2 square root of 5. Because really that in-between step is just making sure that what's inside that radical is not negative. Because if it is, then we have to simplify our I. It's not, so we move down here. Questions on how we got to this point? 6 plus or minus 2 squared roots of 5 over 2. Do all three spots, our 2 on top and the 1 on bottom, have a common factor? Because on top we have 6 and 2 squared roots of 5, yes? Does it share anything with common with our denominator of 2? They all are divisible by 2, yes? 6 divided by 2 is? Our 2 square root of 5 divided by 2 is? Square root of 5. Our denominator, 2 divided by 2 is? It simplifies out completely. So we just get this here. Since the denominator is 1, we do not have to write it. Yes. Yes. Questions on this here? Questions on anything we've done so far? Yep. Last one. We have one more and we're done. Wait, we're too far. There we go. Two x squared plus 4 equals negative 7x. Just to solve this here, we need to get it equal to 0. So we're going to add 7x to both sides. Now, because 7x is not a common factor with 2x squared or 4, we just add it to the center. Now, do we necessarily have to write the ax squared plus bx plus c? No. We don't have to write the a equals b equals c equals. But again, if that does help you keep straight what's a, what's b, what's c, I would write it. Because in this case here, a is 2, b is 7, and c is 4. Quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now our value b is 7. So we can plug it in its two places. Our value of a is 2. And value of c is 4. Now we do need to do some simplifying. Our negative 7 is just, well, negative 7. 2 times 2 is 4. Now, before we start on the radical, so let's look at this here. All right, up here. Does negative 7 and 4 have any common factors? No, there's no way that 7 and 4 is going to reduce. So that means no matter what happens to the radical, this is going to be it. Because if we can't reduce all three spots, this is as far as it's going to go. Now we do need to simplify our radical. If this will let me. Parentheses 7 squared minus 4 times 2 times 4, yes? 17. Square root of 17 is? So that's the answer. Questions on this here?